Good morning everyone. So welcome back to NEET WORLD. So in continuation to the last class, today we will be discussing the molecular weight and little bit about molar masses also. Okay. So in the last classes we have discussed the basic understanding of periodic table and number of elements we have and how we have classified them in the periodic table. The next we have also studied about the basic laws of chemical combinations like law of conservation of mass and law of constant composition or proportions we have studied, law of definite proportions we have studied right now. So now in the last class also I have given one question related to it. Now one more question I will be giving you, you just solve that and just tell me your answer in the comment box, okay? And that will be the thing first we will be starting. And after doing this, yesterday we also discussed about the basic understanding of oxidation state. For an element, if it is in the atomic form, the oxidation state for that element will be 0. If it is in any ionic forms, if it is in positive charges, whatever the total positive charge present on that ion can be considered as its oxidation state. If any negative charge is there, that will be its oxidation state. So this is the story and concepts we have covered in the last class. Right now here we know atoms will combine themselves or atoms combine with other atoms or elements. Now what they will form? They will form a new compounds or molecules. So individually atoms have their own weight, we can call them as atomic weight. When they are combining, we will get the molecules now, that molecules also have some weight, that mass is called or that weight is called molecular weight. Okay, so we are going to discuss about those things now. Okay, right. So just look at this question before I go further. So just look at this discussion that we did in the last classes, law of conservation of mass, which is given by Anthony Leviezer in 1789, and then I told you the total mass of reactants should be equal to total mass of products formed. During a chemical reaction, the total mass should be conserved. The total mass should be same at reactant side and product side. That is what we discussed here. Okay, and before this I explained you about John Dalton's atomic theory, which is given in the 1908. Okay, right. The next, so from John Dalton's theory we can expect a direct question also in the exam, like in the statement based wise we can expect a question from Dalton's atomic theory or this basic law of conservation of mass or constant composition also we can expect. Okay, so this is constant composition is given by whom? Joseph Proust. Okay, so now let us try this question here. See, this is a question I just wanted to give you first. So this question combines both first law, law of conservation of mass, and the next law of definite proportions. Both are included here. You just read the question once, read it and try to solve it. Okay, or just pause the video and try to solve this question first. If you have followed in the last class, you can easily answer this. Okay, right. Yeah. So if there is anyone in the comment box having any doubts, please mention. Just listen to me what I am saying. So now the question given here says the question says that 12 grams of magnesium reacts with X grams of oxygen to form 20 grams of magnesium oxide. So from the given data you just write this equation like this. Magnesium, okay, is there any other color we can have? So magnesium plus oxygen combining to get magnesium oxide. Magnesium oxide. So this is the compound they have told as per the data provided. Now try to balance the equation first. See, for forming magnesium oxide we just required one oxygen atom here. Okay, so it means you can take here just it as half. Okay, so from this data what you can say, when 12 grams of magnesium reacting, we required 12 grams of C as per the equation, if you write it like this. So what about its atomic weight? What do we mean by atomic weight? So atomic weight means atom, like weight of or mass of one atom is called its atomic weight or atomic mass. So weight of one atom of magnesium is called its atomic weight. So how to calculate atomic weight I will give you after discussing this, you just follow here. So its atomic weight is 24. Okay, and now what about this oxygen? For one oxygen atom it is 16, so it means half into O2 is there. So half into, for one oxygen atom it is 16, like that we have 2 now, so right here it has 32, so it will be 16. So 24 grams reacting with 16 grams, so total mass is how much now? 40. So 40 grams, when it is 40 grams of this reactant side, product side also should be 40 grams. How you will get this 40 at the product side? See, for magnesium how much it is? 24, plus oxygen how much it is? One oxygen means I told you 16, so this is also 40 now. Yeah, like this you can understand. Okay, right. Now as per the question, they have taken it as 12 grams of magnesium only. When they have taken 24 grams, we require 16 grams. When they are taking only 12 grams, here oxygen should be required is how much? Half of it, because 24 taken becoming 12 means 16 should become 8. Okay, so now what happens, the total mass if you add, it will be 20 grams. Okay, so 20 grams. They are also saying now amount of product formed here is 20 grams. So from this also you can understand, this question is following law of conservation of mass, and amount of oxygen required is how many grams? 8 grams. Like this you can understand the concept. Okay, so this is about the first question. So similarly, can you do it for second question? 6 grams of magnesium reacting with Y grams of Mg. So I can write that Mg plus O2 gives rise to MgO, half O2. Okay, so now see, 6 grams reacting with Y grams of O2 oxygen to form 10 grams. So as per the law of conservation of mass, what we know, so sum of mass of reactant should be equals to the products formed, mass of products formed. So it means 6 plus Y should be equals to 10. So now Y is how much? 10 minus 6, that is 4 grams. So how many grams of oxygen required here? So 10 grams. So we got X and Y values. So X value there in the question is, as per the question, it is 8 grams, and here Y value is 4 grams. That's it. So first question is done now. The values of X and Y we got. Okay. The next question, if you observe, show that 1 to follow law of constant composition. Show that 1 to follow law of constant composition. See, during the reaction what they are forming, so they are giving you only magnesium oxide right now. So magnesium oxide is given. So now look at this, 12, magnesium atomic number is 12 and mass number is 24. I will tell you how to take the mass numbers for each element in the next, in 2-3 minutes I will tell you. The next, what about oxygen here? It is 16. Okay, now what is the simplest ratio they are going to get here? So 8 3s are 8 2s are. So 3:2 is a mass ratio for magnesium oxide. So even if you take the question also, they told magnesium and oxygen combining as 12:8. 12:8. So 12 grams, see 12 grams of magnesium, 8 grams of oxygen. So in the second question also they have told it as 6:4. So even if you take these ratios also, so 4 2s are, 4 3s are. So here also we got same constant composition now. So this is what do we mean by law of constant composition? A particular element, like particular elements combine to form a particular compound. When that compound is formed from any of the species, they always have a fixed whole number ratio. If a compound is formed from elements, from particular elements, then irrespective of source it is giving that product, always they have a exact composition like 3:2 ratio for formation of magnesium oxide. Okay, so here even you take this question, magnesium, how many grams they have provided here? 6 grams. And how many grams of oxygen we got? 4 grams. So 6 is to 4 means also what is the simplest ratio we are going to get? It is also 3 is to 2. So like that, both of them are following law of conservation of mass and also constant composition. Okay, both of them are perfect here. So I hope this discussion is clear. Right, let us move to the further discussion of atomic mass and all these things, because in the last class I have explained to you about atom. So what does it atom contains? An atom contains, I told you, an atom contains subatomic particles. What are those? So I told you, like proton, neutrons and electrons. So where these protons and neutrons are present, those are in the nucleus. Those are in the nucleus, I told you. Okay, so now when I say atomic mass, see every atom has some mass, so that mass is called its atomic mass. Okay, now atom is a very small particle that we cannot see with our eyes right now. Okay, so it is a small indivisible particle we have studied in the Dalton's atomic theory. Then we got to know there are some other subatomic particles like this. So when I say atomic mass, this is nothing but the mass, atomic mass is nothing but mass of proton plus mass of neutron plus mass of electron. This is what general consideration right now. ఇప్పుడు ఎవరైనా అటామిక్ మాస్ అంటే ఏం చెప్తాం? ఫర్ ఎగ్జాంపుల్ ఒక బ్యాగ్ ఇచ్చా, సో ఈ బ్యాగ్లో ఏ కలర్ బాల్స్, బి కలర్ బాల్స్, సి కలర్ బాల్స్ ఇలా ఐటమ్స్ ఉన్నాయి. సో నేను ఈ బ్యాగ్ వెయిట్ ఎంత అని అడిగితే మీరు ఏం చెప్తారు? ది మాస్ ఆఫ్ ఏ కలర్ బాల్స్ ప్లస్ వెయిట్ ఆఫ్ బి కలర్ బాల్స్ అండ్ వెయిట్ ఆఫ్ సి కలర్ బాల్స్. అంటే వీటిని మొత్తం యాడ్ చేసే కదా మాస్ ఆఫ్ దిస్ బ్యాగ్ ఎంతనో చెప్తాం, వెయిట్ ఆఫ్ దిస్ బ్యాగ్ ఎంతనో చెప్తాం. సో ఇలానే వెన్ దే ఆర్ ఆస్కింగ్ అబౌట్ అటామిక్ వెయిట్, వాట్ యూ నీడ్ టు సే? ఇట్ ఈస్ ద సమ్ ఆఫ్ mass of protons. Okay, let me change the colors. Okay, sum of mass of protons plus mass of neutrons plus mass of electrons. This is what we need to get the idea right now. So now it is found that, experimentally found that the mass of proton is how much? Means it is 1 point, mass of proton is approximate value here I am giving you 1.66 into 10 power minus 27 kg. So it's a very small unit. See, we know 1 kg means 1000 grams. Okay, 1000 grams, and 1 gram is a very small unit, we'll say that is 10 power minus 3 kg. Like this you can write. Okay, so when I say this much, see 10 power minus 27 means it's a very very small value right now. So mass of proton is this much. The next, mass of neutron also almost equal. Okay, almost equals to mass of proton, but exact values it means approximately, if you require I will give you here. Mass of neutron will be equals to 1.67 I have taken here. So everything is same, but a small quantity you are seeing as a different. See a number here, this is 6 I have written, here it is 7 I have written. So what makes the difference? A small unit of neutron mass is greater than proton. Okay, slightly greater. When it comes to electron mass, we have the value around mass of electron around 9.11 into 10 power minus 31 kg. Okay, see now look at these three values. How do you consider them? See, these values are almost equal, but this is further small. So it means mass of electron is almost very smaller when you compare with this mass of proton and neutron. Okay, and how many times it's smaller exactly if I want to count? So mass of electron is very smaller, then you compare with the mass of proton, and mass of proton and neutron are almost equal. Okay, like this you can understand. Now I want exact relation between their masses. So mass of proton will be around 837 times the mass of electron. ఎవరు ఎక్కువ ఉన్నారంట? మాస్ ఆఫ్ ప్రోటాన్ ఎక్కువ. ఎవరికంటే? ఎలక్ట్రాన్ మాస్ కంటే. ఎన్ని టైమ్స్ ఎక్కువ? 1837 టైమ్స్ ఎక్కువ. అంటే ఆల్మోస్ట్ ఒక 2000 టైమ్స్ మాస్ ఆఫ్ ప్రోటానే ఎక్కువ ఎవరికంటే మాస్ ఆఫ్ ఎలక్ట్రాన్ కన్నా. సో ఇలా వెన్ ఇట్ కమ్స్ టు మాస్ ఆఫ్ న్యూట్రాన్, దిస్ ఇస్ 1840 టైమ్స్ ఆఫ్ మాస్ ఆఫ్ ఎలక్ట్రాన్స్. Okay, so what you got to know here, so slightly mass of neutron is greater than mass of proton and least is mass of electron. See, if you observe these things, if you add all these things, the mass of electron is very lesser than the mass of proton, mass of electron is very lesser than the mass of neutron and proton. Andukosame, when we are doing the calculations, we are almost neglecting this value, Why we are neglecting this value? Because its mass is very less compared with the mass of protons and neutrons. Okay, so that's why whenever we are calculating atomic mass, you just take mass of proton plus mass of neutron. This is enough. Okay, like this we are considering. Okay, so now I want a simple way to understand this atomic masses. Yeah, I will tell you. See, when I give you an element like hydrogen, when I am giving an element like hydrogen atom, so now what is the atomic number of hydrogen atom? 1, and helium atomic number is 2, lithium atomic number is 3. Like this you can write. So now helium atom contains how many protons? 1 proton, and hydrogen atom contains 1 proton, that's why atomic number is 1, and number of electrons also 1. Now what about neutrons? So hydrogen atom, that stable element, we are saying it contains 0 neutrons. What I am saying, it contains 0 neutrons. Okay, since it contains 1 proton and 0 neutron. See what I told you, mass of electron we do not need to consider. So the total mass of hydrogen atom should be 1 plus 0. So total mass of an atom to be taken as proton plus neutron mass. Okay, so how many protons are there? 1 plus neutron mass 0. So this will be 1. Like that you can consider. Okay, so you told these values and you are taking 190. How you are taking this means, this unit, this is a smaller unit now. So this number I am considering as 1. అంటే ఈ నెంబర్ని ఊకే ప్రతిసారి అక్కడ రాసే బదులుగా మనం ఏం చేస్తున్నామంటే ఈ యూనిట్ ఏదైతే ఉందో 1.66 ఇంటూ 10⁻⁻27 అని దాన్ని 1 యూనిట్ అనుకుంటున్నాం. ఓకే, అంటే ఈ వాల్యూని ఒక యూనిట్ అనుకుంటున్నాం. సో 1 hydrogen atom, how many units? 1 unit. Okay, how many units? 1 unit. Okay, when I say helium, how many protons it has? Mass number is 2 now, right here 2. Okay, I mean atomic number is 2 now, right here 2. And helium atom contains 2 neutrons and also 2 protons and also 2 electrons. Okay, now what is its atomic mass if I ask for helium? Yeah, so what I told you, don't consider electrons, only consider these two things. Okay, see electron ki mass of proton ki neutron ki almost equal value kada. See these two values are almost equal now. So you just add these 2 units. 2 plus 2 how much? 4. So 4 units will be the mass of atomic mass of helium. Like that if you do for lithium, atomic number is 3 and it has 4 neutrons. How many neutrons? 4 neutrons. Okay, remember this, 4 neutrons, and electrons will be 3, but we need not to worry about electron count. Okay, because mass of electron is taken only from proton number plus neutron number. So this is how many times? 3 plus 4, 7 units. Okay, like this we are keep on calculating the atomic masses. Okay, so now if you take it for carbon, so carbon contains 6 protons and 6 neutrons and 6 electrons, but no need to worry about this electron count, just add these 2 numbers, so it will be 12 units. Okay, I hope it is clear. The next, for nitrogen we have atomic number 7, so protons are 7, neutrons are also 7, and what about this? Electrons are also 7, but no need to worry about electron count, just add these 2 numbers. So we got it as around how much? 7 plus 7, 14. Okay, for oxygen it is 8, so 8 plus 8, okay, it will be 16. Okay, like this if you observe the given trending here, I mean trends here, so it is almost, if atomic number is 6, mass number becoming 12, if atomic number 7, mass number becoming 14, means you are just doubling the number right now. So this story, this understanding, this whatever the trend is there, it will be very suitable up to first 20 elements, because almost for first 20 elements mostly you will be seeing their number of their number of proton count and also neutron count are nearest to each other. So that's why if you sum them, if you add them, you will get the double number like this. Okay. Now, sir, what is the use of studying this? See, this is carbon is a atom. Now, carbon combines with hydrogens and forms a methane molecule, and carbon combines with oxygen and forms carbon dioxide. So, these are called molecules. What we can call molecules. Now, what is a molecular weight, they will ask. So, what is the molecular weight of methane? How can you calculate this? See, how many carbon atoms we are seeing? One carbon atom. So, 1 into, if there is one carbon atom, 1 into, okay. So, one atomic mass, carbon యొక్క atomic mass, how much I told you? So, atomic number is 6. So, it contains 6 protons, 6 neutrons. So, 6 plus 6, 12. So, 1 into 12, like that. How many hydrogens are there? 4 hydrogens are there, into. For each hydrogen, what is the mass number I told you here? Starting one, it is 1. So, you can take it as 1. That's it. So, simply add them, 12 plus 4, it becomes 16. So, this is your answer for the discussion. Okay. I hope it is clear. Now, tell me for carbon dioxide, how can you solve this question? So, for carbon, I told you it as 12. Okay. And how many carbons are there? 1 carbon is there. Oxygens, how many are there? 2 are there. So, each oxygen mass, how much? Atomic mass is how much? I told you at the bottom, 8 plus 8, 16. So, add here 16. So, 2 plus 16 to is 32. Okay. So, total 32. Here it is 12. Okay. So, this total sum becomes 44. Like this, you need to do the molecular weight of a compound. So, atomic weight means what? Weight of one atom. Molecular weight means what? Weight of one molecule. That's it. This is very simple. Okay. Now, I will be giving you few questions for practice purpose. You tell me for them. So, C2H5OH. So, this is called ethyl alcohol. What is this? Ethyl alcohol or ethanol. So, we will be using these in our daily life also. Now, tell me, how can you calculate their molecular weight? So, it's very simple. What I told you, take number of carbon atoms, 2 into. Each carbon atom has 12 mass. How many hydrogens? 5 plus 1, 6. Into each hydrogen mass I told you as 1 plus. How many oxygen atoms? 1. Okay. And each oxygen mass is 16. So, add these numbers, 12 2s are 24 plus 6 plus 16 1s are 16. Okay. So, this becomes 30, 46. So, total sum is 46, like this. Okay. Right. Now, let us take little bigger molecule. Don't scare by looking at the molecular structure or formula. So, C6H12O6. What is this? This formula will be suits for glucose. So, you can say it is a glucose. So, now tell me what is its atomic weight for carbon, multiply with 6. Atomic weight of hydrogen, multiply with 12. Atomic weight of oxygen, multiply with 6. So, the total sum you are going to get as molecular weight of glucose, which is equals to 180 units. Okay. So, how can you do? 6 into 12 plus 1 hydrogen atoms are how many? 12 are there. So, 12 into each hydrogen mass is 1. How many oxygen atoms are there? 6. Okay. Each mass of oxygen is 16. So, you add this everything, you are going to get it as 180. So, this is how you need to do. Okay. As a practice purpose, I just want to add few more examples. You just do it on your own and tell me in the comment box. Okay. And first practice question I am giving you, H2O, water. Second one is H2SO4, sulfuric acid. Very important. All these we are going to use in our complete class 11th and 12th discussions. Randomly we will get all these things. Okay. It is better even if you remember those weights also. Okay. And third thing is urea. So, they simply mention urea. So, what is the formula of urea? So, you need to know that. Okay. How can you write this? CO, NH2 twice. NH2 twice. Okay. This is the formula of urea. You just find its mass number. Then next they will mention something like this. They just mention acetic acid. You need to get this acetic acid. Okay. Solve all these things and mention your answer in the comment box. Okay. And fifth one is sucrose. Okay. These 5 are enough now. As of now, these are enough. Okay. Right. You need to answer me all these things. Okay. One last I just wanted to add, sixth one, as SO4 2- sulfate ion. Okay, you do all these things and mention your answers in the comment box, finding their atomic weights, then finding their molecular weights. So what I am asking you, mention all the molecular weights for the given 6 examples. All these 6 molecular weights you mention in the comment box. Just try it, even if it is wrong, no issues, but you need to try them first. Okay, so now make a note or take a screenshot of this discussion so that it will be useful for your reference. Everyone, is it done? Yeah, let's move forward. So just give a try to all those homework questions which I have mentioned on the board. Yeah. So now let us discuss few more things now. So we have completed till now, we have completed about atoms, molecules and their atomic weights and molecular weight. Okay, so now we will be giving you something interesting here. When you consider, like I am discussing about atomic weights and these things only, atomic weights and molecular weights only still. Okay, so what I am saying is, when we go for a shop, what that shopkeeper will do, when we ask him to give me some kg of tomatoes or something like that, so what he will do, he will take the weighing machine like this. Okay, so one side he will keep something like a iron stone or something like that, he will keep having some quantity. So it is considered as standard unit as 1 kg. Then whatever the items we are asking, so he will keep this side and he will measure the weight, like he will measure the weight of that particular item. For example, if I ask tomatoes as 1 kg quantity, so he will keep tomatoes here, keep on putting tomatoes. When it becomes equal, he will say, yeah, this is the 1 kg of tomatoes you can take. Like this he will say, na. So this is a normal thing that we will be using in our daily life. So similar to this, when it comes to atoms, atoms are very, very small things now, we can't even see them. So to measure that atoms, we also required some units that expresses these atomic weights. So now what are the units we are using? So that units here generally considered as atomic mass unit or something like relative atomic unit, relative atomic mass unit, or this is also given as unified mass unit indicated with symbol U. Okay, so what I am saying, atomic mass unit, AMU. What is that? Atomic mass unit. So what is the use of this atomic mass units? To express mass of atoms. What is it? To express mass of atoms. See, similar to the kgs, like when I say kg tomatoes, here kg is a word used to express the quantity of a substance in the bulk. But when I am talking about very atomic level, there the quantity used will be atomic mass unit. So how can we say this atomic mass unit? See, it's very simple. Similar to this story whatever we discussed, again I am constructing the same. To take the weighing machine, okay, here I have two atoms. Let us say this is A, this is B. What I am saying, A and B. Now if they are equal, this line is, if it is like this, then I can say both atomic weights are same. But I am saying that atomic weight of A is greater, atomic weight is greater, so greater than this. So it means what I am saying, with respect to one I am expressing the weight of the other thing. Like that, when it comes to chemistry, they have taken C12 as a standard unit. So what they have taken? C12 as a standard unit. So when they have taken C12 as a standard unit, they found that they have taken C12 in the one side of this weighing machine, okay, and they have found another side they have taken one proton. What they have taken? They have taken one proton, okay, H plus ion, let us consider. They have found that the proton mass as 1 by 12th mass of C12, mass of 1 by 12th mass of C12 atom, carbon atom. It means what does this line says? ఈ కార్బన్ యాటమ్ ని, ఈ C12 కార్బన్ యాటమ్ ని మనం 12 పార్ట్స్ డివైడ్ చేసాం అనుకోండి. ఇలా 12 పార్ట్స్ డివైడ్ చేశాక ఒక పార్ట్ తీసుకొని ఈ సైడ్ దాంట్లో పెట్టండి. సో నౌ దట్ వన్ పార్ట్ ఆఫ్ దిస్ 12 parts will be equals to hydrogen atomic mass unit or proton mass unit, okay, like that. So now 1 by 12th mass of C12 is there now, so this is called 1 AMU, 1 AMU. So here you can observe, I told you, relative mass unit with relative to the C12 carbon, the given element, how many times it is greater or lesser is called a relative atomic mass unit. Okay, now what is the volume of value of relative atomic mass unit? That is 1 AMU. So this 1 AMU mass unit is nothing but the value that we have seen for proton. How much we have seen? 1.66 into 10 power minus 27 kg. So this is the AMU value. Okay, remember this is very important. Okay, now what is the mass of proton? You can simply say it is as 1 AMU. Okay, so now when I have discussed about hydrogen atom, that's why you have told it as 1 unit. What is this U indicates here? Unified mass unit or 1 AMU. So exactly we want value means you just represent it like this. Okay, that's it. Okay, so even for 12 carbon 12, so carbon 12 means how many things you can say? So it is divided into 12 parts now. If I add all those 12 parts, it will become 12 AMUs, 12 AMU, or you can simply say 12 units. That's it. Okay, no confusion, nothing. So just make it like this. So similarly, if I take nitrogen atom, so nitrogen atom, there you have written it as 14 units, or you can also say it as 14 AMUs or 14 units, like this. Okay, so now they can also express this molecular weight in terms of grams, gram atomic weight or gram molecular weight for molecules. So what you need to do, just the same value in grams, you write it in same value with grams, that's it. So that's it, like this you can express. Okay, now CO2, if I ask what is its gram molecular weight, so take molecular weight, put the gram beside of it. Okay, so how much it is? 44 units I told you now, 44 AMUs you can say, or if I ask particular gram molecular weight for this, 44 grams you can write, 44 grams you can write. Okay, so without having any confusion, I hope everything is clear whatever we have discussed till now. If you have any confusion, please let me know in the comment box. I will discuss them once again. If no confusion, let us move forward. See, they have mentioned it as a CaCO3. I told you already with 5 examples as a homework I also mentioned. So calcium atomic number is 20, so mass number becomes 40. Okay, because it contains 20 protons plus 20 neutrons. Okay, carbon atomic number is 6, its mass number becomes 12. Okay, double it. Okay, and there are 3 oxygens, each oxygen atomic number is 8, mass number becomes 16. Atomic number is 8, mass number becomes 16. So 16 threes are, you can take here. Okay, so 40 plus 12, 52 plus 16 threes are 48. So total sum will be how much? 100. So 100 atomic mass units. AMUs you can say, or simply U you can write. Okay, if I ask for gram atomic weight or gram molecular weight for this, gram molecular weight same value in gram unit. That's it. Okay, I hope the discussion is clear. If you have any confusion, please mention in the comment box, and you must solve that 5 or 6 questions, whatever the homework questions I have given in the discussion. Just 3 slides back I have mentioned now, so that you need to answer in the comment box. Okay, now one more term here we have is average atomic mass. So what do we mean by average atomic mass? See, when I am extracting a metal or any element, what we are going to get? We are going to get all the isotopes of an element. For example, carbon if I consider, so when I am extracting carbon from the earth crust, I am going to get a mixture of carbon isotopes. It means C12, C13, C14. So what is this isotopes? You are using a new word? No, in the last class also I explained. So isotopes means elements with different mass. I mean species having same atomic number. All of them are having atomic number is how much? 6 only. But their mass numbers are different. The species with the same atomic number but different mass number are considered as isotopes. Okay, so whenever we are extracting carbon from the source, from its source, let us say carbon is extracted from the earth crust. So when I am extracting the carbon from earth crust, we are going to get mixture of all its possible isotopes. Okay, that is what, if you are taking anything like occurring naturally, if we extract it out, we are going to get all its isotopes. Okay, so these are the things. Okay, now if I ask what is the average atomic mass of this element, you need to consider this isotope and its mass, this isotope and its mass, this isotope and its mass. So add all these things, sum of all these masses will be taken as average atomic mass of the carbon. Okay, for better understanding, let us consider chlorine. Okay, because chlorine has only 2 isotopes, so simplifying is easy. Okay, so when you extract chlorine from its source, okay, so you are going to get a mixture of all its isotopes. So how many isotopes I told you? Chlorine has 2 isotopes. Okay, so one is Cl35 and Cl37. So what are the isotopes of chlorine? Cl35 and Cl37. So when I am extracting this chlorine, I will get Cl35 as 75%. How much percent I am going to get? 75%. Okay, and Cl37 as 25%. How much percent it is? 25%. That's it. Now what I am asking? Average atomic mass, average atomic weight of an element like chlorine is equals to what is the Cl35 isotope composition? 75%. So percentage abundance means how much abundance we have for chlorine 35? 75. So 75 into 35 plus Cl37 is how much? 25. So 25 into 37 divided by 100. So this gives you, the overall calculation gives you average atomic weight of chlorine. So now upon simplifying this, you are going to get this value as 35.5. How much you are going to get? 35.5 units. So this is the average atomic weight of chlorine. So whenever we are calculating, whenever we are doing the calculations, we need to take this value as the atomic weight of chlorine, because when you extracting chlorine, we can get all these mixtures, no? So that's why 35.5 you need to take. Okay, I hope it is clear what do we mean by average average atomic mass. Okay, and you know the same question even asked in JEE and also in the NEET, EPSET, in different manner they will be making the same question. Okay, now I will tell you one simple way to use this formula. Whenever they ask in the exam, you can just use this formula. Average atomic weight is equals to summation of percentage abundance of that isotope, into its atomic weight. into its atomic weight by 100, because we are taking here percentage, no? That's why divide it with 100. Okay, once again, see, percentage abundance for chlorine 35 is how much I told you? 75. That's why the number here I have taken as 75 into what is its atomic weight for this 75% composition? 35. So 35. Next, for next summation means you need to all those isotopes possible. Next, 37 into 25. Total sum 75 plus 25 is 100. Now you take here as 100. That's it. Upon simplifying, you will get the average atomic mass. Okay, hope this discussion is clear. Guys, if this is clear, please click on the like button and mention in the comment if you have any confusion. I have told you one thing, U or AMU. AMU means what? Atomic mass unit. Okay, U also, we can also indicate this with U, unified mass unit. So both represents what? 1/12 the mass of, 1/12 the mass of carbon C12. So what is your answer for here? 1U stands for 1/12 the mass of carbon C12 atom. So it should be the answer you need to choose. Okay, next. So look at this question. They have mentioned like this. How can you calculate this? Ethyl alcohol molecular mass they are asking. Already I explained the same question in the previous 10 minutes back, previous discussion. Okay, you tell me what is your answer again. So what I told you, 2 carbon atoms are there, 2 into atomic weight of carbon. So 2 into 12 plus hydrogen atoms, here 5, here 1, so 6. So 6 into atomic weight of hydrogen, that is 1. So plus, next, how many oxygens are there? 1 into atomic weight of oxygen, that is 16. So 2 into 12 plus 6 into 1 plus oxygens are 1 into its atomic weight is 16. So upon simplifying, 24 plus 6, 30 plus 16, 46. So where do we have this? 46 units, first answer. Okay, hope this discussion is clear, right? Let us move forward. Yeah, so you can do for all these questions which I have mentioned here. Even the data also provided, you just solve them and mention your answers in the comment box. See guys, without knowing calculation of molecular masses, we cannot do anything in the chemistry. ఓకే, ఈ మాలిక్యులర్ మాస్ అంటే ఏంటి, అవి క్యాలిక్యులేషన్స్ ఎలా చేయాలో తెలియకుండా మనం కెమిస్ట్రీలో క్వశ్చన్స్ సాల్వ్ చేయలేం. సో క్వశ్చన్స్ సాల్వ్ చేయలేమంటే మనం ఎగ్జామ్లో కూడా ఆన్సర్స్ ఇవ్వలేం. ఓకే, నాట్ ఓన్లీ కెమిస్ట్రీ, ఇవి మీకు ఫిజిక్స్లో యూజ్ అవుతుంది. అండ్ మీరు ఇన్ కేస్ ఇఫ్ యు ఆర్ ఎ బయాలజీ స్టూడెంట్, ఇట్ విల్ బి యూస్ఫుల్ ఇన్ యువర్ బయాలజీ ఆల్సో. Okay, because in biology also we are discussing about respiration, photosynthesis, all this process. There again you will get molecules like carbon dioxide, oxygen, iron in hemoglobin, like that we will be discussing now. So everywhere these things comes. Okay, you need to focus on this very basic thing first. Okay, yesterday we discussed about this. Yeah. So now I just wanted to bring slowly into the mole concept. Now what do we mean by mole concept here? I will tell you one simple way. See, when you go to any shop, what I am saying, when you go to any market, so you will be asking the shopkeeper to give you something like dozen eggs. What you will be asking? Give me some dozen eggs or dozen apples or dozen bananas, you will be asking. So the shopkeeper will give you 12 eggs. How many eggs he will be giving you? 12 eggs. Okay, like that when you go to a chappal shop, like footwear shop, you will be asking, give me a pair of shoes or chappal or whatever footwear you want. Okay, so what he will do, he will give 2 shoes to you, right? Now 2 shoes to you. Okay, so what do we mean by these words here? Dozen means 12, pair means 2. Like that, there is one more term, gross. Gross means 144 units. How many units? 144 unit. For example, I am saying 1 grass of pens or 1 grass of pencils. So that shopkeeper will give you 144 pencils, okay, like that. So when it comes to chemistry, we are using a term called mole. What we are using? A term called mole. See, 1 mole if I use, that shopkeeper will give me this many number of atoms or particles, 6.022 into 10 power 24. This many particles, he will 23 particles, okay, 23 particles. 6.022 into 10 power 23 particles, whatever may be. So when you go and ask shopkeeper to give dozen eggs, he will give you 12 eggs. And grass pens gives you 144. Pair means he will give you 2. Okay, like that if you ask 1 mole, that represents Avogadro number of particles. What is this Avogadro number? This much big number it is, 6.0022 into 10 power 23. ఓకే, అంటే ఇక్కడ మోల్ అంటే మీరు ఏదో కన్ఫ్యూజన్ లాగా అవ్వాల్సిన పని ఏం లేదు. సో మోల్ అంటే మీకు ఎలా అర్థం కావాలి, మోల్ ఈజ్ నథింగ్ బట్ జస్ట్ లైక్ ఏ డజన్. డజన్ అనే టర్మ్ మీకు తెలుసు కదా, మనం చిన్నప్పటి నుంచి వాడుతున్నాం. డజన్ అంటే 12 ఎగ్స్ అని, డజన్ ఎగ్స్ అంటే 12 ఎగ్స్ అని, యాపిల్స్ డజన్ యాపిల్స్ అంటే 12 యాపిల్స్ అని. సేమ్ అలానే మీరు కనుక 1 మోల్ యాటమ్స్ అన్నాం అనుకోండి, 1 మోల్ యాటమ్స్ అంటే అందులో 6.022 ఇంటూ 10 పవర్ 23 నెంబర్ ఆఫ్ అటామిక్ పార్టికల్స్ ఉంటాయి. ఎందుకు సార్ ఈ వర్డ్ని మనం ఎందుకు వాడుతున్నాం కెమిస్ట్రీలో అని అంటే, యూ మైట్ హ్యావ్ ఎ డౌట్, సార్ వై వీఆర్ యూజింగ్ దిస్ మోల్ యాజ్ ఎ వర్డ్ ఇన్ ద కెమిస్ట్రీ. సో ఎందుకు అని అంటే, సి వెన్ యూ సే ఎ స్మాల్ cup of any chemical substance, that chemical substance contain many number of particles, many number of small particles, because atom is very small particle that we cannot see with our eyes. అంటే మీరు కొంచెం సబ్స్టాన్స్ తీసుకున్నా కూడా అందులో చాలా పార్టికల్స్ ఉంటాయి, చాలా అటామిక్ పార్టికల్స్ ఉంటాయి. ఆ నెంబర్ చాలా ఉండే అటామిక్ పార్టికల్స్ చాలా ఉంటున్నాయి అంటున్నాం కదా. సో వాటిని సింపుల్గా ఎక్స్ప్రెస్ చేయడానికి మనం ఈ మోల్ అనే వర్డ్ని వాడుతున్నాం. ఎందుకనంటే if that small quantity contains this many particles, then you can say this term as a 1 mole. ఓకే, సో మనం అసలు ఇది చదవడం వల్ల యూజ్ ఏంటి సార్ అని అంటే, సి మనం ఏం నేర్చుకున్నాం, వీ హ్యావ్ స్టడీడ్ అబౌట్ వెయిట్, అటామిక్ వెయిట్ వీ హ్యావ్ స్టడీడ్, అండ్ నౌ వీఆర్ స్టడీయింగ్ నెంబర్ ఆఫ్ పార్టికల్స్ ఇన్ ద గివెన్ సబ్స్టాన్స్, అండ్ వీఆర్ లింకింగ్ ఇట్ టు ఎ నెంబర్ కాల్డ్ మోల్. అంటే దీనివల్ల ఏమవుతుంది సార్, ఈ మోల్ కాన్సెప్ట్ వల్ల యూజ్ ఏంటి సార్ అని అంటే, వెన్ ఐ సే ఇట్స్ అటామిక్ వెయిట్, సి మీకు ఒక 12 grams ఆఫ్ కార్బన్ ఇచ్చాను. సో ఐ హ్యావ్ గివెన్ ఏ 12 grams ఆఫ్ ఏ కార్బన్, అండ్ ఐఎమ్ ఆస్కింగ్ యూ టు కౌంట్ నెంబర్ ఆఫ్ కార్బన్ పార్టికల్స్ ఇన్ ఇట్. అందులో ఎన్ని కార్బన్ యాటమ్స్ ఉన్నాయో చెప్పండి అని అడుగుతున్నా. So you no need of counting it like 1 carbon, 2 carbon, 3 carbon, because we cannot count it also. It is not possible because we cannot see with our naked eyes right now. So what you need to do, so you just take 12 grams of carbon. Now you relate it to how many moles. Now 1 mole contains this many particles. So ఇది ఎన్ని మోల్స్ తెలుస్తే మనం ఎన్ని పార్టికల్స్ డైరెక్ట్ చెప్పేసేయచ్చు విత్ ఇన్ సెకండ్స్లో. సో అందుకే ఈ మోల్ కాన్సెప్ట్ అనే చాప్టర్ని మనం చదవాలి. Okay, so what is the use of mole concept? It deals with the micro level particles and connect it to the number of particles and amount of substance and how much volume it can occupies. Okay, so all these stories. So now why again, is there any other uses of it? See, yeah, it has many usages. For example, we are writing hydrogen react with oxygen. What I am saying, hydrogen react with oxygen forms H2O, water molecule form avutundani cheptunnam. So balance this like this. So from here also you can say how many moles. So here as per the equation 1 mole ante 1 mole hydrogen react avvadaniki how many moles of oxygen required? Here half mole of oxygen is required. When 1 mole of hydrogen and half mole of oxygen is combining, we may get 1 mole of water molecules. అంటే ఈ వాటర్ మాలిక్యూల్ ఎంత ఫామ్ అవుతుంది, లేకపోతే ఈ వాటర్ మాలిక్యూల్ ఒక 18 grams ఫామ్ కావడానికి నేను ఎన్ని గ్రామ్స్ హైడ్రోజన్ని వాడాలి అండ్ ఎన్ని గ్రామ్స్ ఆక్సిజన్ని వాడాలి అనే క్లారిటీ మనకి మోల్ కాన్సెప్ట్ ద్వారా వస్తుంది. So what is the use of understanding mole concept? The amount of product formed during a reaction or amount of reactants required to get a quantity of product everything comes from the calculation that we are using from mole concept only. So without mole concept there is incomplete chemistry. You cannot do anything, because chemistry అంటే ఏంటి, ఫైనల్గా ఒక రియాక్షన్లో ఎంత ప్రోడక్ట్ ఫామ్ అయింది, లేకపోతే ఆ రియాక్షన్ జరగడానికి నాకు ఎంత రియాక్టెంట్ కావాలి, స్టార్టింగ్ మెటీరియల్స్ ఎంత తీసుకోవాలి, ఈ క్యాలిక్యులేషన్స్, ఈ రిలేషన్స్ అన్నీ కూడా మనకు ఎవరిస్తారు, మోల్ కాన్సెప్ట్ అనే చాప్టర్ ఇస్తుంది. సో ఈ చాప్టర్ని మనం అంత డీటెయిల్డ్గా చదవాలి. ఓకే, రైట్. సో the complete discussion of mole concept will be starting from tomorrow. You just join these sessions every day without wasting your time. Okay, just 1 hour of chemistry you can listen. Okay, so that for the next 30 days, if you complete your complete basics plus the bridge that you required from 10th to 11th, everything will be easy and your life will be easy in your 11th and 12th classes. Okay, నేను ఏం చెప్తున్నాను, సో ఈ నెక్స్ట్ 15 days, నెక్స్ట్ 15 to 20 days ఇలా డైలీ 1 hour కెమిస్ట్రీ క్లాస్ అటెండ్ అవుతూ ఉండండి. సో మీరు క్లాస్ 11th 12thలో ఈజీగా ఫీల్ అవుతారు. కెమిస్ట్రీ సబ్జెక్ట్ జరుగుతున్నప్పుడు, క్లాస్ జరుగుతున్నప్పుడు ఈజీగా ఫీల్ అవుతారు. ఓకే, సో యూ కెన్ బి ఎనీవేర్, యూ జస్ట్ అటెండ్ ఇట్ ఆన్లైన్ ఓన్లీనా, అటెండ్ ద ఆన్లైన్ సెషన్, డూ సమ్ ప్రాక్టీస్ ఆన్ దిస్, దట్స్ ఇట్. ఇట్ ఈస్ మోర్ దెన్ ఎనఫ్. Okay, so don't waste your time simply chit chatting with others or looking at the reels or some kind of stupid things. You just enjoy your holidays, but also follow these discussions. Okay, so thanks for watching. Stay connected with our NEET World channel. If you have any concerns, please write in the comment box, or you can directly reach out to the mobile number provided in the description box. Okay, yeah, meeku edaina batches gurinchi details kavali ani anukunte, whatever the mobile number provided in the description box, you can contact them for reaching us to get more details about our batches. Thanks for watching. Stay connected.